minutes until everyone joins. Hi, are you there, Shravan? Are you only the?
Good afternoon. Yes, yeah, I'm available.
Okay, so no one has come now. Yeah, so we can start the tutorial.
Sure. Yeah.
So if you have any queries from, or is it, this is going with the class, or is it uh, like the next lectures? What about that? Is it going
Uh,
in the flow or?
Now, currently, whatever we had that this week assignment, that least square approximation was discussed in the class.
Mm,
But these equations, whatever now we are seeing, like truncation errors.
yeah,
So
yeah.
that was not discussed.
Okay, okay,
At least some initial first, say, 3 to 4 questions are on that truncation errors.
okay. So let's try this first question, maybe in this assignment. Let's see. You practiced the spline questions before?
Spline last week we did, but in that also I have one small doubt last week
Okay,
assignment.
okay,
Probably I will just check that particular question.
okay. And was the
Uh,
assignment fine
yeah,
last week? Yeah.
assignment is fine. Only one question I had a difficulty means
Okay,
maybe my understanding is not correct. Probably it's question number 6 in the
okay.
assignment. That is with respect to a function which is given as like 0, f of
Mm,
x is 0 if it is in
mm,
the range of -1 to minus zero point 0.5, that is x
mm.
greater than or equal to -1 and less than or equal to minus zero point 0.5.
Okay.
And the second thing is that f of x, the same function is defined as 1 minus 2 mod x
Yeah.
if x is in between minus
Okay.
zero point
So
0.5 to plus
what
zero point
I
0.5.
do is you can email me that one.
Sure, sure, sure. I'll do that. Yeah,
Okay. Yeah. If okay. So let's discuss this first question. Maybe you should
fine,
try this for the
fine.
next.
Yeah,
So if S is a natural, you know what is the natural cubic spline? Do you remember? Natural.
yeah. Yes, double dash of
Oh, what
x
happened?
naught.
It's not
That is
working.
like two conditions we told.
Just what was that? The natural spline. So we have like I just say S naught and so S naught. What was the natural spline condition? Do you remember?
Yeah, yes, double dash of x naught and the end initial and end of differentiation should be 0.
At X naught, it should be zero. Is it?
The xn also, yeah, and the xn yes, double dash xn also is equal to 0.
Is it for natural or clamped? For
Again,
natural.
natural.
Yeah,
Clamped it
yeah.
is
For
first
clamped, what?
differentiation. First differentiation. That is
First
s
difference.
dash of x naught and s dash of xn.
It is same as this.
Yeah, yeah, yeah.
Okay. Okay. So have you used these things in your assignments? Were there?
Yes, yes, yes.
Okay. That's good. Mm. So if S is a natural cubic spline that passes through the points, the value of this derivative with respect to x at x equal 1.5 most nearly is. So tell me, do you understand this question, what it is saying? Okay.
It is like passing through the points where the common
Yeah.
nodes are 2 and 3.
So points are, what are the points we have? 1, 2, 2, 3, and 3, 5. Wait,
Yeah,
3, 5, right?
yeah. 1, 2, 2, 3, and 3, 5. And 2
Okay,
and 3
so
are
the
common
spline
nodes.
is passing through the points. It means that let f be a function which has values f1 is equal to 2, f2 is equal to 3, and f3 is equal to 5. Okay. So now you have to find a spline which passes through these points, and you have. Mhm. Okay, so what is the way to find a natural spline? Do you remember what we do? S naught x. So how many intervals we have now? 2, 2, 3. I think 2 only. Yeah.
Yeah.
And what is S naught x? It is a cubic, right?
Yeah.
Can I take this? -1 plus. And what is S1x? It is it is B3, let's say, plus B2. You understand, right? Okay, so how many conditions do we need here? How many conditions? 8 conditions, right?
Yeah.
So I won't solve it, but I just recall what we have done. So first, how many continuity condition you have? S naught at 2 should be same as S1 at 2. S naught at S naught prime at 2 should be same as S1 prime at 2. And S naught double prime at 2, it's same as S1 double prime at 2. Really? These things. And these are 3 conditions. Other conditions, do you remember? Yeah, natural one. Natural spline
Natural spine.
conditions.
Yeah.
So I won't write again. These are 2. These are 3. And you need 3 more. So where the 3 comes from? Where the 3 comes from? Do you remember? Yeah, you can use this, right? So S naught 1 is same as F1. S naught 2 is same as F2. And S naught S1 3 is same as F3. Clear? So these 3. So you have total 8 conditions and you can find out all the coefficients. Then what the question is saying, once you got the coefficients, what the question is saying to find out this derivative of x at x is equal to 1.5. So ds by dx. So which function is s now? S is S naught, right? Can you find now what is dx? Derivative of S naught with respect to x. And then you can substitute x is equal to 1.5. Clear?
Yeah.
Any
Probably.
questions?
Yeah. Can we do that just quickly? Derivative and x is equal to 1.5 will give the function that should be fine.
At x equal 1.5, it will give in terms of A3, A2, A1, and A
Correct.
naught, right?
Correct. As a
But
equation.
you
Correct.
have
Correct.
found out these
Yeah.
things already from
Yeah.
these.
Yeah.
Okay, you can do this.
Yes, this is Mayuresh here. I joined
Yes,
little late.
Mayuresh, you want to have any
Just
queries?
yeah, just one small doubt. Just can
Yeah.
you go little up? This S naught
Okay, okay,
X and
okay.
S1 X, no?
Yeah.
Yeah, can you just quickly explain once again how did we arrive at that? The
How we evaluate the
polynomial.
coefficients, you are saying?
No, that's okay. Coefficients are okay. How do we decide the S naught X and S1 X, A3, A2, A1, no? That polynomials.
Yeah.
Why
We
you
just
why you took X minus 1? Yeah.
yeah. So what we do is we try to get some polynomial which basically starts from this point. Okay. So
Okay.
this is the general form we take, x minus x naught xn, like this. I don't know, but we have to always start from the initial point. Here initial point is 1, and in the second case you see here the initial point is 2. We should start with these ones. Anything
Okay.
you can start from 3 also, it doesn't matter. Yeah, it's just
But
a form we are.
it should be the limit of the limit either one of the either end of the series, is it not?
Yes, yes, because
Either
it will
one
be
or two
easy,
or
right?
three.
It's easy to if you substitute 1 here in this equation, then it's just, you will get a naught easily. But if you take just any other polynomial like x cube plus, it will be more complicated for solving the
Yeah,
equations.
right,
So
right.
for our easiness, we take this. Otherwise, no. It's,
Okay, clear.
Mhm. You can take and taking at endpoints is easy because you have conditions at endpoints, right? So implementing them makes so easy. Yeah. Any doubts?
If you can explain a natural spine versus clamped spline once again, just in a minute, it will be really grateful.
Okay, okay.
Yeah.
In natural spline, okay, I just explain using the conditions. Yeah. So in natural spline, you can see these types of conditions, right? At the initial point, x naught is 1 here and x2 is 3 here. So at endpoints, basically, you want your function to have double derivative should be 0. It means that first derivative is given by the constant, right? Constant at something,
Okay.
making to be more smooth. I don't know, like that. And at clamped
Okay.
conditions are just
Curvature
more
would be zero.
precise. Yeah.
Yeah.
In the clamped condition,
In
you take
clamp,
directly from
yeah.
function. You don't take your
In clamp,
derivative at
this.
endpoints to be constant, but you take the value of the function's derivative.
No, I did not understood clamped one.
Yeah, in clamped condition, in the natural spline, what does this imply? It's basically implied s dash x naught is some constant, right?
Yeah,
Sn.
right.
But here, you don't take it to be constant. You take to some function value, right? Which is already given to you, which is more precise in sense.
Okay, but means why I asked this question, no, in the last assignment, which is already
Yeah,
over now,
yeah,
it was told to derive the polynomial using clamped condition, but at the
okay.
same time, it was not like the condition was not given. F dash was not given.
F was not given in that?
F dash was not given. F dash at x naught and x and
Okay. Um, okay.
I just
Wait a second.
okay,
I
okay,
just recall these conditions are right. Last time what I've done. So yeah, it's just these are conditions. But you can always approximate this f prime. So if it is not given to you, then you can always do like f prime x naught is basically fx1 minus fx
see these
naught by.
conditions. This condition means the data should be data is required, is it not? But data was not available in the last assignment.
Function data is not
I
available.
it was okay. But Saravanan sir, do you remember this
Do
or
you remember
it's
anything,
something
anyone?
wrong?
I will ask if.
Myrosh, is question
Okay, no
number
issues.
8? Question number 8. Hello.
Yeah, last question. Yeah, last question number 8. You are correct.
Okay,
I
that is like
assumed something and gone ahead.
yeah, that is
Yeah,
having this x0, x1, x2, which is given as x0 as
yeah,
0, x1 as 0.05, and x2 as 0.5, 0.1. Sorry. Then question is like
okay.
if we, that is which means that interval closed interval in between the closed interval of 0 to 0.1. So three values were given 0,
Yeah,
0.05 and 0.1. And if
yeah,
we find the
yeah,
cubic spline f with the clamped boundary conditions that interpolates f of x equal to x power 5, find the value of f
yeah,
dash of 0.08.
yeah. I like that question. Yeah. So, but okay, then how to invoke this clamped boundary condition there? How did you do it?
Probably what I did, I can explain, and Yash can confirm whether
Okay,
it
no
is
issue,
okay.
sir. I'll give call to you later. No
No,
problem.
no issue, no issue. Just
We
probably,
can.
for my understanding also, I just want to know whether it is correct. So what I did is that
Yeah,
like I have taken this f of x is x power 5. So to apply this clamped boundary condition, we go for first derivative, that is f dash of x, which is 5x power 4. f dash of
Yeah.
x. So for that f dash of x, if you put the value of f dash of 0.08 only is asked. So directly when you substitute the value, you will get the answer. But without
but
even
that's too
applying,
simple a
without
method, no?
even without even applying the intervals.
No, but then okay, that's a very straightforward answer,
Yeah,
no?
yeah,
But we
yeah,
haven't, yeah,
yeah.
yeah,
But really,
because we have
the
not
other
gone through
things
this
are
fine
useful or
procedure.
not, we have to see.
Yes, you
Yeah.
got it, no?
Okay.
Because x raised to 5 is a function, y is equal to x raised to 5.
Yeah.
And it was told to derive y dash, that f dash of 0.08.
So it
So
was
simply
clearly
5,
mentioned that you need to use clamped conditions in the question.
yes.
And your function is given in tabular form, is it?
No. It
No,
is
no,
just only
it
f
was
of x
simply,
equal to x power 5.
Okay, fx is x, then it's fine. Why
no,
not?
but
You
then
can calculate
how,
f dash x.
no, that okay, that's a very straightforward answer, no? Because we have to,
Okay.
as it is told that you have to use a clamped boundary condition.
Yeah.
That means, and then there was an interval given 0 to 0.1.
Yeah. So at 0, f dash 0, you know that, right? F dash 0.1, you know.
Okay, for like that you are okay.
Yeah.
As
Yeah.
interval is given, f of x is given, so f
Yeah.
dash is naturally known in that
Yeah.
case.
Yeah.
Okay, right.
That's what I'm saying. Yeah.
Okay, probably if I have a doubt, I'll come back again. Yeah,
Okay. You just look at that question. Maybe in meantime,
yeah, I
if
know.
you. Okay. So is it clear now? I stop the clamped conditions. Maybe we can come to next question. Okay.
Just to answer in this particular question, we are getting this d of 0 by dx as a function of a3, a2, and a1.
Yeah.
Like that, we are getting for different clamped conditions when we apply. We will get in terms of a3, and each equations we have to solve for a3 and individual coefficients, right?
Yeah. Yes.
Okay.
So I won't do much on clamped and natural. I will do move on to new topic. Has it been discussed
Fine.
about
Yeah.
the derivative approximations in the class?
No. This time it was only the least squares of polynomial. The derivative approximations are this truncation error difference was not discussed.
Yeah. Okay, maybe I can discuss them if it is. What form does the truncation arrow take for the difference formula? So,
Yeah, this was not
okay.
discussed.
Okay, let me discuss this one. So how do you approximate a first order derivative at a point x, right? How do you approximate? So you know the function approximations using polynomials, interpolation you done, and the spline you have discussed, we have discussed for function approximations, but for derivative approximation, we have not discussed at a point. So what we do, you know Taylor series expansion? Remember?
Yeah, f of x0 plus h, no? That
Yeah, so fx
is
plus
equal to
h
f
is
of x
basically fx
of
plus
x
h
plus h into
f
f
prime
dash
x
x,
is
x
h square
square
by
by
2
2.
f
Yeah,
prime,
correct.
and this move on, right? Until that you have to specify some, the rest of the term you say error term, maybe. Or I just write here that if I want to stop here, making it more complicated, if h is very small, then we can neglect those terms, right? So okay, so if h is small, so we can, means I'm still writing here till this term, say double dash x. So I just stop here for the expansion. So it is like an approximation, right? So fx plus h minus fx by h is equal to f dash x plus h by 2 f double dash x. Clear? And okay, so what this term is basically, this term is error term, truncation error, what I say, because you are truncating. So the order is basically order of truncation error is the value of h to the power 1. If it is h to the power 1 here, then we say order of truncation error is order of h. If it is, so here h is raised to the power 1, so it is a order of h. So if you remove this error, basically, then you will get an approximation that f dash x is approximated by fx plus h minus fx. That you know the definition of f prime x. Okay, you understand this?
Yes, I understood.
Okay, let me see what. Yes. So here, can you tell me what is the truncation error now? Can you do that? So they have said that f dash x is approximated by fx plus h minus fx minus h upon 2h. Okay. So we need to find truncation error. So fx plus h, like the earlier one, we try to do Taylor series expansion, fx plus h, f prime x. Let's say it will go to h square by 2. Don't want to go more, or we can go more if you. And fx minus h is basically fx minus h prime. Just replace h by minus h. Okay. Now, which one is true? What is the truncation error? So you just do the same thing what they have done. Fx plus h minus fx minus. So once you subtract both the things, then you get 2h, and this becomes plus 2h cubed by 6 divided by 2h, right? So you get f prime h square by 6f. So what is the order now? Can you see now? What is the order?
Order is 2, right? But still we are able to divide by h, on the other side.
We
Yeah,
have
it is.
divided. Yeah.
Okay.
So what is the power? It's 2. So order of h square. Truncation error. Like this. So there can be any such approximations, and you need to find what is the truncation error in this. Okay. Yes, till now, if you have any issues, let me know.
Can we see the question? Like this is the order only we have to tell. Like double dash of x, the order is h square means it is 2. That much only.
Yes,
Okay.
it's just an approximation, and this is error basically.
Okay. Clear. Probably that question also I just copy if you can just flash it.
Which question?
Oh, the same question.
Okay.
I've written in notebook. Probably if it is there, I'll just make one. I can copy also. The other
Yeah.
other one, question paper.
Okay, the above question.
No, not this one. The other paper, your question paper.
Okay, let me see. I should copy this question there. Or
It will be useful because the
okay,
continuity will be
yeah.
there.
I used to. I forgot. Yeah, you are right. Let me know that. How to copy? I forgot. I will be. Okay, where should I copy it? There's no space. Okay, I can. You can see from here, maybe. Right?
Yeah. Okay.
So is this type of questions maybe in the assignment? Can try. Okay, let's discuss. I won't go with line. Now we will go with backward difference formula to approximate the derivative. So the formula that I have discussed is what you do you know any difference between forward and backward? So when you go in forward in time, so this formula consists of increasing h, right? Until x. From increasing h to, so this only consider these points x plus h and x. So it is forward, right? Because it is moving forward in time. And this formula is forward and backward. This consider 2 points x plus h, x and x minus h. So this is forward, backward. So it is central. It is like a center. So central. It keeps the point x in the center. So it is a central difference. So now we discuss backward difference.
We can copy the question also.
Yeah, I just copy that. First, I discuss backward difference formula. So what is backward difference formula is fx minus h is basically fx minus h prime x plus h square by 2 f triple prime. Maybe it's just a error. What we used to write like this in Taylor series expansion, where psi belong to what we say some small interval, say x not xn. I don't know. This is an error term. So what we do is, so here f prime x is what value of x? It is fx minus fx minus h by h, right? So this is backward difference, okay? Now, use backward difference formula to approximate derivative of sin x at x not equal 0.6 with h equal 0.1. Okay, so if fx is, okay, I just copy that question. You're right. I forgot to upload the last week recording. So I've uploaded that. Okay. Yes, how do you do that? Now, anyone? Any guesses?
Same thing, expand using Taylor series with this.
No, you don't need to expand it.
Oh, then straight away, then f
Just
dash
use
f-
this formula.
Yeah,
So
yeah.
what is this? F prime x is basically sine x minus sine x minus. So here it's x naught, right? So just substitute these values. What you get? Sine 0.6, sine 0.5 by 0.1. Okay. Yeah, that is the approximation. It's easy.
Okay, it is 0.852, correct.
Yeah. Okay. If we are using forward difference formula to approximate the derivative of ln x, determine the bounds for the approximation error. Okay, let's discuss this. If x is ln x. So tell me what is the, okay, I just copy this question. Yes. Now what your job is to just calculate approximation of f prime x using the forward difference. Can you do that now and tell me what is the approximation? Just take 5 minutes. Just do that. You know the formula, right? Just do that and tell me. Then we will discuss about the approximation error bounds here. But first tell me the approximation.
Here f of x plus h minus x by f of x divided by h.
Yes.
Okay, I got f dash x as 0.54607.
Okay. Is it what you got, Shravan?
I'm just calculating. Give me a moment.
0.54607.
Yeah.
Okay. Now, let's discuss. Okay, whatever, you should do that. But let's discuss the approximation error bound. So what is the error? Tell me.
Okay,
What is the
by
truncate? What
the
is the order of
formula.
trunk?
Yeah.
It should be h by 2 f double dash. Yes, maybe. So it's like h by 2 f double dash. So what is ln x? Derivative of ln x, it is 1 by x and minus 1 by x square. Double derivative. So it is. Okay. So what should be the bounds for the approximation error? Can you tell me? Yes. So if you take the mod of it, then it should be like mod h by s square into 2. And it will be
Will it be
like,
plus and minus same thing?
it should be less than equal to something. So what should be the 1 by s square is always less than 1. So it should be less than 0.1 by 2. And what is that value? It will be like, what
Yes,
is
from there this minus 1 by s square has come. I misread.
0.05 something. Yes, what are you saying?
This minus 1 by s square. Whether that is okay. That is second differentiation.
Yeah.
Yeah, that f double dash of s from there it has come.
F double dash.
No, this truncation error formula you have written h by 2 f double dash of s.
Yeah.
So that f double dash of s, how it has become minus 1 by s square?
Because f prime x is fx is ln x, right? So what is its second derivative?
Okay, okay. So that first derivative is 1 by x. Okay, minus 1 by x square. Okay, fine.
Yeah.
Right.
So if the error bound is this, then what are the suitable bounds you can take? It should be greater than equal to, I don't know. Should be none of these then. Yeah, it should be none of these. It should be none of
Can you
these.
explain the last step? Can you explain the last step?
What we done here?
Yeah, yeah.
The bounds, we try to give the bound, right?
Yeah.
So assume s is greater than 0 because ln function, log function is defined for s greater than 0. So 1 by s square is always less than 1, right?
Why you are taking s? It's x, right? Same thing, is it?
If s is greater than 1, then 1 by s square, sorry. Yeah. What are you saying?
I'm not actually. This is f of x is given, right?
Yes.
f of x is ln x, so it should be where from
Yeah,
this
it
s
doesn't
is coming.
matter.
I'm
You
not
take
getting.
X or S, it doesn't matter.
Okay, in that
No,
case, it will be
yeah,
h.
yeah.
Yeah,
Yeah, yeah.
in
What
that case, it
Mayurish
will
is
be.
asking, I understand. Probably now we are putting h by let it be x square or s square.
Yeah.
Y value
Okay.
of s should be what is the value of s in that case? What we should approximate, because we
Yeah.
have that they already given 0.8, like x as 0.8 or 1.8.
So I should start from 1. Yeah.
I
That's
Yes.
what is
I
the
actually
confusion.
I would have made an error in judging this, because h by 2x square means I would have directly entered x is equal to
Because you
1.8
know the
and
graph
would
of
have
1 by S square, it's like this.
yeah.
And when X is greater than 1, then it will be bounded, right? Otherwise, it's not bounded. So S should be greater than 1. X means X. Yeah.
My doubt is that why we cannot put x as 1.8, why we are going with 1.
Okay, wait. X has 1. X should be greater than 1.8.
No, no, in this truncation error, if I want to find the, okay, it is a bound only they are asking. Okay.
Mm-hmm.
So which means directly we are taking S as 1 and
Yeah.
the H as 0.1. It is
So
given as
wait. If you want, yeah, wait a second. Yeah. So ideally you should take X greater than equal to 1.8, because what happens is that the question is saying you just use forward difference approximation. You don't know the value before X, right? Before X to be 1.8. You don't know what is the value of fx. Suppose f for x less than 1.8, then just take the interval to be x greater than equal to 1.8, then it should be s greater than equal to 1.8, and it should be less than equal to 1 by 1.8 square, right? Should be divided by. Yeah. Now tell me.
is 0.0154.
What's the value after dividing?
0.0154.
Yeah. Okay. Yeah, that's what they want to say. Yes, this
No, but
option. Sorry.
it is
Now
not the
this.
bound, right? It's not
It's
the
the
Correct, that
bound.
is
bound.
It's
also
only a
correct.
discrete.
Correct, that is a point. It is not a bound. We are
It is
telling only
not.
the error.
It is the error bound. Yeah.
Oh, error. Okay.
Any doubts in this? Any problems? Why I have corrected it from 1 to 1.8? Any problems in that?
Yeah, I'm clear actually. Now I got it clear, because I was thinking it should be 1.8.
Why? Yeah, because the forward difference formula says that you only have the function approximation, you only have point x and x plus h, not below x. Okay, so you can't go below 1.8. You have to move forward, right? So that's why I've taken interval to be greater than equal to 1.8, not 1. Wait a second, I just connect my charge. Yes. Is it understandable or clear?
It's clear.
Clear? Okay.
It's clear.
Yeah, clear.
Yeah.
Yeah, so let's discuss. Mhm. Yeah, so let me discuss the least squares approximations. Uh, that this is a little bit least square. Now I discuss, just wait for a second. Okay, so let's do that. Hmm. So you're given. So has it been discussed in the class, least square approximation?
Yes, yeah.
Okay. So find the least square line approximating the following data. So it's a very big data. We just take a small one, maybe. So let's say I don't want to do this one, but I do some another question. Suppose the data is given like this, that it's like 1, 2, 3, 4, 5, and it's 5, 4, 3, 2, 1. Okay. So you have to find the line approximation of this data. It's similar to what we have there. Then, so what is the straight line equation? Yes, what is the straight line equation?
Y equal
Y
to
is
mx.
equal to a plus bx. Yeah.
Yeah.
Then what we have to do, we have to calculate, we have to sum this y. So here x is this and y is this. We have to sum this y and use this equation if it is like this, b summation x, because here, yeah, and this summation xy is a summation x plus b summation x squared, yeah, like that, for this type of data. And here n is, how much n is here? Yeah, so this summation x is, okay, n is how much it is? Yeah, so n is the degree of the polynomial. I think no, it's not that. N is, yeah, so n is, sorry, n is the number of points. So how many points we have? N is 5 here. Okay, so we do that with it. I will discuss this approximation maybe more clearly coming sections, but for this type of data I'm discussing now. So you can find all these numbers: summation y, summation xy, summation x, summation x square, and summation x. Can you do that? What is summation y? What is summation y? What is summation y square? And what is summation xy? Tell me. Can you look from the table and tell me these things? These three things. Summation y means sum all the y values.
That is 15.
Or
15.
yeah. And what is summation y square? Can you solve that?
Y square is not required, right? Is it required?
Yeah, it's not required. Yes. Yeah. Sorry, summation x square. Yeah.
Summation x square is 55.
55. And summation xy
35.
35. Okay. So you can substitute these values here, and you can solve this after that system of two equations. So I just tell you this is just for if you want to use this formula for for a small set of points, or if you want a linear approximation, then you can use this formula. But for general one, I think you don't need to use it. Maybe just recall it once. Or how to derive this formula, basically, that I want to make sure you understand that. Yeah, wait a second, I just open the book. Yeah, so what we do is just a second. Yeah, I just do this. Okay. So if you have in general how to derive this one is that so least square, straight line, and quadratic fits for straight data. So if data is provided at points xi, yi, I from 0 to n, then and let px is equal to c naught plus c1x be a line approximation to data. Then what we do, we try to make this difference I equal 0 to n. This is what we call as yxi. This is yxi is basically yi, so I just write yi instead of yi minus c naught plus c1 xi. This difference should be minimum as possible. Okay, this difference should be minimum as possible. You're trying to compare two curves and you want this line. So the difference between this line and a curve should be minimum as possible. Okay, at every point. So how do you find a minimum of a function? If you have an equation, minimize fx over. So how do you find the minimum function minima? How do you find minimum values, minimum or maximum values function can take? Can you tell me how do we find for general function fx? How do we find its minimum?
We take first derivative and set it to 0.
Yeah. Okay, like this. So it's just an I, say I it is. Then what you do, how do you find the minimum? You take first derivative, del I by del s, but with respect to C naught and with respect to C1 here to 0. And so from these equations you get, so what is the first derivative? From first equation you get this thing. I just write here. 0 and okay. And from second equation you get okay. Yeah. So further simplification gives you this equation C naught n plus 1 C naught. You understand this? So this is your, this is your equation. This is a 2D system. And you can solve it, right? Any problem here? Proof? So this is for straight
For me, it
line.
is
Can you?
clear. Yeah.
Yeah?
Yeah, it is clear for me.
Okay. Can you do it similarly for quadratic interpolation? If P2x is like this one, C naught plus C1x plus C2x squared. Can you do it for that? Yes, tell me. Just try this. Try this same proof with, instead of here, you just take your second degree polynomial and take the first derivative and second derivative and third derivative. In that case, 2b0. Okay, I don't write it, but you do that. We rewrite that expression also. Just do that. Take 5 minutes. Just do that.
Can you scroll little up? Yeah, okay. Little down, please. Yeah. Shall I tell Yash?
Yes, tell me.
Yeah, so these three equations are there. So
Okay.
del f by c, del c naught is equal to 0, c naught, c1 is equal to 0, and c2 is equal to 0. So with that, first
Hmm.
equation is c naught plus c1 summation x, c
C
naught plus
naught.
c1 summation x plus
Yeah.
c1 summation x plus c2 summation x square is equal
Yeah.
to summation y.
There is no n
Next
here.
equation is okay, c naught into n will be there finally.
Is it like
C
that?
naught over is it n plus 1? I guess it is n. It should be summation
Wait.
over that series, no?
Okay,
Yeah,
I
it
believe
should
you.
be.
And another one?
Second one is C naught summation x
Yeah.
plus C1 summation x
So there
square.
should be some pattern, you see.
Yes, there is a pattern. So
Let's
it is
just
something
try.
like x is multiplied further.
Wait,
C1
wait, wait.
summation x square,
Just
C2 summation x cube.
yeah, wait. Yes, C naught summation xi, C1
Plus
summation
C
xi square.
x plus C2 summation xi cube
Okay.
is equal to summation xi.
Yi, right?
Yeah, xi yi.
And third one,
And last one, C naught summation xi square plus C1 summation xi cube
plus C2 summation xi4.
C2 summation xi is equal to summation x square xi square yi.
Okay. Is it right? Are you sure?
Yeah, okay, Saravanan is also going to verify. It is
Shravanand,
correct.
are you
This is what
there?
I got.
Yes, yes, it is correct only. Only thing I have a doubt that first one C naught whether we will have that n.
Yeah.
Otherwise, rest
That is
are correct. Yeah.
that is over summation, no C naught over summation. So summation will
Yeah.
be the number of degree of freedoms.
Okay. So n plus 1 is basically the number of variables, right? Sorry,
No,
not
is it n
variables,
plus
the
1
data
or
points.
Yeah, yeah, it
okay?
is
So
Because
we
data
are
points.
you are
starting from
seeing n.
0. You see, we are
I
starting
got
from
your
0.
point because you are
Yeah.
starting with 0. That's why. Okay,
Yeah.
I was simply counting the numbers.
Yeah. N plus 1 is total number of data points.
Yeah, this
And
both were
if you are
solved.
worried about why we take an have there n, because we have started from n, we just take n plus 1 anyways. But it will not change. N will always be 5, or n plus 1 is always 5 here. You just take n plus 1 for convenience.
Yeah, both these were solved in the classes.
Okay, these are solved in the classes.
Yeah, yeah.
That's good. That's good. Okay, I just recalled it. So you can do the first question, I think, find the least squares line approximating the data. It is a big data. And if we fit the following data with least square polynomial of degree 2, what is the total error E? What is the total error? What does it mean? What is the total error? At which point? Should mention at some point. Like at 0.5, it should mention that the yeah, so the total error E at some point at 0.5. Let's say it should mention like this. So what you
Shall
do
we?
in that? You know how to calculate error?
Probably shall we do this?
Uh, I should do this or not? Because the way you get some polynomial, right? Some approximation to P2x, right? You get P2x something. And you just have to calculate
Maybe
the.
since the number of points are very less, can we just try once?
Okay, we can try because it's just square. If you want to solve it, you can. But yeah, it's quite okay. I just replaced something from the question. Maybe we can try one question because other and one question from this also. We can try one question from this. So find the least square approximating for the polynomial of degree 1 on the 2 for the function on interval 0, 1. Can we try question number 8? It seems to be have less points.
No issue, but still the other one, earlier one, can you explain how to? You're explaining it. We can.
What like how to
The error,
implement?
error.
Okay, you want to discuss about error. Okay.
Yeah, yeah.
Okay, let's okay, what I do is let me do. You understand how we implement least square method?
Yeah.
Okay. without solving that much actually. We just say that here at some specific point. Suppose using the least square method, approximation, we got this polynomial p2x is equal to some say 0.5x squared plus 0.1x plus let's say 1. Then what is the value of p2 at? Because we want to checking the error at 0.5. So what is the p2 at 0.5? You can calculate it, right? This is some number a, and y at 0.5 is coming from the table, right? This is 1.6487. So what is the error? P2.5 minus y.5. Okay?
Yeah.
Yeah, it's like this. And you know A, you know everything. Clear?
Clear. Yeah.
Okay, find the least squares approximating polynomial of degree 2 for the function on the interval. So we are given on the interval. So let me paste this question. We can implement this method and you tell me what's the values for it. Yeah. So it's here. Okay. So only 2 points we take, 0 and 1. Okay. So what is x? X is basically 0, 1, right? And y is sine pi x. So sine pi 0 is, what is sine pi 0? 0. Sine pi 1 is sine pi and 0. Right? How many points do we need for that? Let's say 1 by 2 is also 1 point. Then sine pi by 2 is 1. Okay. For a second order polynomial, you need 3 points at least. Right? Mayuresh, you want to say something?
No, go ahead. I'm getting it.
Okay, so what is x naught? This is, oh, okay, let me write that way. Okay, just write this way. Yeah, x naught, x1, x2, and y naught, y1, y2. Okay, so how to do that? Can you apply that formula here? Here, in that case, what we got? So how many terms you need? Summation xi square, summation xi cube, summation xi4. Just calculate these terms and tell me what are these. And you can solve it. Yeah. And you have summation xi, summation yi.
Do we need that much xi cube and xi power 4?
Wait. What are you saying, Shravanand?
No, do
Do
we
we
need
need
up
that?
to calculate xi cube and xi power 4 also?
Yes.
Summation of this?
Yes. We need that because we have quadratic interpolation, right?
But the equation itself, answer itself is not more than x square. No?
What are you saying?
No, the polynomial, whatever equation we are seeing is not above x square. No? It is what?
Saravanan
It's
said that so over summations
approximating.
we are taking x raised to 4, but finally the square polynomial you will get.
Yeah.
Okay.
Just now we have
Okay.
seen the proof. No, in that proof also you need x raised to
Yeah.
4.
You need
Okay,
C0,
fine.
C1, C2, these three coefficients, nothing else. Yeah.
Okay. So for that we need to, okay.
So for
Clear.
these, you need to solve three equations.
Clear,
And
clear.
you
Yeah.
can you find out them?
We'll do it quickly.
Okay. And just by using the tell me the word values you are getting by substituting. Okay, maybe you can try this. Finally tell me C0, C1, and C2 directly. What are these values using the formulas?
Sarvanan sir, if you are doing it, you can tell. Frankly speaking, I was not doing this sum. Okay. Yeah.
Harish, I got this equations. Probably that I
Yeah,
can
yeah,
tell
yeah.
we can
Sorry.
clarify. Probably
Yeah,
again
it's
that coefficients,
actually
if you are
yeah, it's
solving by matrix, it will take its own sweet time. So probably we will
yes,
just
yes.
Have you
verify
got
the equation.
three equations? Have you got?
Yeah. Probably that we will just I'll tell Myrisk you can verify. Um,
Okay.
First one
No,
is
you go ahead. Actually I have done only
What
halfway, and
values you
okay,
got?
we can go ahead.
that is I have to solve for this C0, C1, C2,
Yeah,
but
yeah,
the
yeah.
equations I can tell. First one
Okay.
is 3. Probably in place of C0, C1, C2, I have taken as ABC for convenience. 3A plus 1.5B plus 1.25C equal to 1.
Mm.
And then the second one is 1.5A
Yeah.
plus 1.25B
Mm.
plus 1.125C
Mm.
equal to 1.5.
Mm.
Then third one is 1.25A,
Yeah.
then 1.125B,
Mm.
then 1.0625C
Yeah.
equal to 1.25.
Okay.
Probably we
Are you
have to
getting
solve.
same, Mayuresh?
Yes, we can go ahead. I really sorry, I did not do it full.
Okay, okay. Yeah, you can solve these equations and you can find out the value of ABC. Okay. The concept should be clear to you.
Yes,
Otherwise,
yes.
everything is calculations.
Yeah. So once we get this one, then what next?
Yeah, once you got this one, you got ABC, right?
Yeah.
And you finally got your desired polynomial P2x.
Yeah.
Okay.
Yeah.
And then you can substitute the whatever value. Yeah, you can check the options.
Fine.
Okay.
But okay, directly we will get that equation, right? That's fine.
Yeah.
Yeah, that is correct.
Okay. Till now we have discussed about the polynomials, but you can do in similar way for the exponential functions like this. Okay.
Can we just do only one out of 8, 9 or 10, only one if possible?
Yeah. You can try one. For a simple data, not this one, we can try for b to the power x. Okay.
Yeah.
So if you have, so you can apply this same logic with every type of function, right? Like you have done with the polynomials. Now you understand the method very well.
Yeah.
So what we have to do, we have to just do this. Suppose data is given at x size where x naught to x's. Sorry, I is from 0 to n. Xi yi, okay. Then what we do is we consider this sum yi minus, it is just a function say sxi uh, should be minimum, right?
Yeah.
And your sxi is any function, right? Earlier we have case 1, we have taken sx to be c0 plus c1x, right? As case 2 we have taken like this, any general function you can take an cn to the an x to the power n plus an minus 1x. Okay. And you can take any exponential function a to the power bx, right? Anything. And it continues like which case you want. So here you want to approximate some data, right? So I just take only 3 points, say 1, 2, 3, and 1, 1, 1. Say it's just easy. X, Y, So what your job is to do, you just want to approximate using function Sx is equal to a to the power bx, okay? Then how should I do it? Like the previous method, del I by del A should be 0 and del I by del B should be 0, right? So what type of equation should I get here? Can you tell me?
Yes, one small information in lecture. There is one more method what
Yeah,
Sir was explaining by taking natural logarithm and
yeah,
converting
yeah.
it into a linear function,
Oh, that's also good. Yeah,
so that it will be like a single easy step.
yeah, yeah. So log Sx is basically what is the log A e to the power bx? It is log A plus, is it that function log
Yeah,
B?
yeah, natural logarithm. In place of log, it is natural log. If
Mm,
ln
i-
Sx, then
is it log bx?
exactly.
Okay.
No, it will be once you put in natural logarithm, you will get only bx. Ln e, natural
Oh yeah,
logarithm
yeah,
of
yeah.
e.
Sorry,
Yeah.
it is just bx. Yeah. Yeah, you can do a similar analysis. So whatever you got at the end, you just take the, inverse log. So you just take the e to the power of that approximation, then you will get final. So at some, if you want that particular value, yeah.
Can we do it for that problem what you have shown?
Yeah. What is that? Yeah. For this problem, we can try or
Yeah, just one because this is like a common. Okay, problem. It is.
it's like a linear approximation, is it? Or
Yeah. Converting it into linear function and approximate it. Then finally take the
Raman sir,
like.
yeah, it will be linear approximation. And for example, in this case, now y is equal to b into e raised to ax. So it will be ln b plus ax.
yeah, yeah,
So ln b will be your actually constant,
yeah.
whatever was in earlier thing. And we will calculate if all the constants. And again,
Yeah,
we
it's
will go
just
back to the
we have
whatever was
done that
happening.
already, right? We have taken
Yeah.
C naught to be log A and C1 to be 1.
Exactly. And we will get the values of C naught, C1, and finally
Yeah,
we'll put in this and find out A and B.
yeah, it's similar.
But just
Okay, so suppose what I do is, suppose from the linear approximation, you get the value of C naught to be 1 and C1 to be 2, right? So from a straight line approximation of a data using least square approximation, though once you get C naught C1, then uh, you just take log A equal to 1 and log B equal to B is exactly 2, right? Because B is same as C1. So A will be e to the power 1, e to the power C naught, basically. Okay. So you do the same way, taking log A plus bx. You just do the approximation, taking not log A and B, but here you take C naught and C1 instead of log A and B. Then you convert into A and B like this. Is it confusing? Or I write properly this thing to explain? Yes.
can we do that problem here actually just to get because that equation I have one small doubt. Can you go to the question?
Okay. Wait.
That eighth, the ninth one. So here, okay, we have to consider the same table, whatever given there. Okay, that is
Yeah.
a big number, right?
Yeah.
So the table is very big. Yeah,
Table is very big here, but a straight line approximation, it's easy, right?
correct. That is correct. But okay, fine. It'll take some time. Yeah, correct. What you told is correct. Straight line means it is easy.
So you
Finally,
just
some
need to
all.
find the straight line approximation. You don't need to worry about log A and B, whatever. You just do what I'm saying is you just take this data and you do the same thing that we have done over here. Where it is here. Okay, in this question. So here it's the data, right? The same data is there. You forget this thing. Okay, you forget it. You just find this straight line approximation. You will get C naught and C1.
Correct.
And from that, you can find A is e to the power c naught and B is c1. Just clear? It's very easy now.
Yeah, yeah.
Or B is actually B is sorry, A here it is B is coming first, so I just write like this. Just note it down how to convert it. And in this question, how will you do it? Bx to the power A?
Here also the same way applies. No? We can take same route.
A log x, you know?
Yeah.
Like that. But here you have log B plus A log x. Is it similar? No, it's not similar. Is it a linear approximation? No.
Yeah, here this also can be solved as a linear, no?
How it sound as a linear log function? It's not linear, right? It's non-linear.
No, no. What I am telling, we can just convert to same y equal to ax plus b. That way we can solve, then finally convert that into e power. What are the values we are getting?
No. In this question, you can't. In that question, it's different. You have to go by the formula that I have said. This one. Where? This one. Yeah, this same type of formulas that we have done. This one. You can't convert into linear form, right? This one. Can you convert bx to the power a to something like c naught plus c1x?
Yeah, it is in lecture it was told like that. Like a lecture I will explain.
Yeah.
Lecture the
It
case
is
2 is
possible,
described.
yes. Y is
Yeah.
equal. Yeah, it is possible.
How? Can you tell
Take
me?
log of yeah, it will be log b plus a log a, whatever you have
Yeah,
written.
so
No?
it
Same
will be
thing.
log b plus a log x.
Yeah, is
But
equal
it
to
is
y
not
and
linear, right?
no. What we will assume is log x. We will assume as x.
Okay, you are assuming it. Okay. But in general, it's not a linear equation that I'm saying. Just I want.
Correct. That is fine. But
Yeah,
still
yeah.
to get a solution easily, like when we convert this into this form,
So you are
then
saying
finally
that you take replace x by log x and take the sum and all these.
it's the same way what we did for earlier. We will solve this equation,
Yeah.
then
Okay.
can take the e power. Whatever the values we
Yes.
are getting, take the e
Yeah.
power, we will get that
But
values
ultimately,
eventually.
what you get is something like using this. Okay, you ultimately get log b and
Log
a log
x,
x
a log x,
equation like
a log.
that. Okay,
Yeah,
you
yeah,
can take e power of that. Yeah, that's fine.
exactly. Yeah.
Yeah, that's correct. Yeah, but you can't. Okay, you cannot find like here. It's a bit okay. Like, but you have to start with this type of data, right? In this question, not C, not C1x, not this form, right?
No, it will be in that only. Like when we convert it into the linear equation, we will be solving through that only.
But what is C1 here? What is C1 here? Okay, so you want to convert like this. So C1, it's
Exactly.
like C1 Z, say Z is log X, C1 is
Yeah,
A. Okay, so you have three
yeah.
variables now.
Exactly. Yeah.
Okay.
And can you please show that earlier question number 9, just for the total
Yeah.
answer? I didn't noted options.
Question
Question
number
number
9.
9.
Okay.
Yeah, here itself. Yeah, the table also along with the table.
Yeah.
Just slightly if we can go. Yeah. Okay. Fine.
Yeah. That's all today. Yeah, if you have any questions now, you can ask.
Yeah, there is one more in the session. There is like similar to this, a function is given x power 0.5 and an interval 0 to 1. Using evenly spaced points with step size of 0.25 means we have to go from 0.25, 0.5, 0.75 and 1.
0.5, 0.25, 0.5 like that.
Okay, clear.
Yeah.
Okay, right. Thank you.
You understand least square now for any general polynomial, any general function you can approximate, right?
Yes, yes, it is clear. It is clear.
I've shown the method, general method anyways. If you are not able to solve it like using log, you can always do by general methods.
Sure, sure, sure. Right. That system of equation other than matrix, do we have any easy way like our other again we have to go for approximation only, na?
Yeah, yeah.
As in exams, it will take a lot of time. Any way where we can get that answers like a system of equations quickly?
It will be easy in the exam, not
Okay,
tough.
okay.
Yeah. Here in assignments, they are just won't make it lengthy.
Yes, Okay, thank you
Yeah.
for the class. Shall I leave? Actually, it is clear.
Okay.
Yeah,
Yeah. You
yeah.
can.
I have exam tomorrow.
Okay. All the best.
So yeah,
Yeah.
yeah, yeah, yeah. Thank you. Yes, if possible, next week, please change the timing.
Oh, yeah.
Yeah.
I was busy today, so I haven't changed the timing today.
Okay,
But yeah,
okay,
from the
okay.
next
Anyway,
time,
if
maybe
possible,
I.
you change it. Otherwise, also no issue.
We only have 3 classes left, right? After that, but
Yeah, yeah,
still,
yeah.
I.
But okay.
Okay. Uh,
At
let's
least
see.
summary class, the last class, if at all there is a summary class, you keep it on some other time.
I was just afraid to shift because we in weekends we used to plan for some visit outside. So
Yeah, yeah. Okay,
sometimes,
no problem. Yeah, yeah, no
yeah.
issues.
Okay.
I'll take a leave. Thank you.
Yeah. Any doubts, Shavanan, you have?
No, you should just once again, yes, that last my assignment, there was one question probably that I will send you a mail.
Okay.
It will be helpful if I am getting the steps how to go, proceed.
Yeah.
Yeah, and this time I think all are like whatever we discussed only in line only it is there. So probably that is that may not be that difficult.
Yeah.
Only thing that just if for exams again one concern is there.
When you have exam of this?
Likely by I think it is 28th next month, coming month.
Okay.
27 or 28, one day it is
So
there. I
we
think
have a one
27.
practice class before that, 1 hour.
Because now for 4 more weeks now, we are now in week 9. So 3 more is there, 3 more weeks.
3 more weeks, and there is one practical, one session for practice session.
Okay, fine. So that will practice session will fall on 20th, I think. That case. Now we are having 23, 23, 30 is
Yeah.
there on Saturday, 6 and 13, then 20.
Mm.
So 4 Saturdays is there, which means fourth
So for
Saturday will
that,
be.
I will just do some exam related questions on
Yeah,
last session.
that will be helpful
Yeah.
because either for myself and Mayuresh, we are not directly from this core field directly,
Okay.
but we are trying to get it
Which
because
field are
already.
you from?
No, I'm from
What you
chemical.
study?
Yeah, I'm chemical engineering. I did my chemical engineering, but now already there almost like for 43 now. I am for my
Okay. You have
PhD.
done chemical engineering.
Yeah, chemical engineering. But actually, to be frank, in chemical engineering, my 5th semester we had this numerical methods. So after
What
that,
work you do nowadays in chemical engineering? You are a scientist, right?
yes. I'm working in a propellant field, like propellant production section in VSSC, ISRO.
Okay. Okay.
So
What type of work you do? Like,
now I am a deputy general manager here. Like now already 20 years in ISRO.
okay. Okay.
Like we are having major facilities for production of these propellants, chemical propellants, whatever we are using for launch vehicles and satellites.
Yeah. Okay.
So that is my area, and Mayuresh is working in a different area.
Okay. Like that
So
Chandrayaan, you have worked on it, or
yes. We have
you
our
have worked that? Okay.
yes. Our propellant is there in Chandrayaan still and more.
Propellant. Okay.
Yeah.
That's
Which
good.
one? It's
You
a
are
chemical
working
propellant.
real for the nation, not like us.
Anyway, it is an opportunity what was given, and we are very proud of being there in ISRO.
Yeah.
Anyway,
That's,
that's what actually now that this PhD part also it was like long due. Now only we took that attempted, but at least
you
for
have
me
done
now
PhD
already.
also, or
No. I'm doing for the PhD. One of the coursework is I need to have a mathematics also part of it as a coursework.
okay.
So since nowadays, since we are working in office, as an like an opportunity, they was given through NPTEL where we can study and take the
Okay.
credits.
You found this job interesting or not? This ISRO.
Yes. Now
Yeah.
already
Okay.
that's why I told no joined in
Okay.
2004. Now almost close to 20 years.
Yeah. You are satisfied, much satisfied
Very
with
much,
job. Oh,
because we are
that's good.
directly contributing something to the people.
So in that job, I think salary doesn't matter or matters if we, yeah. but salary is not the only thing. That is.
No issue, no issue. Because like for ISRO, there is I understand there is people are well paid. No
Yeah,
issue.
there it's like.
Yeah, yeah.
Mm. So ISRO has collaborations with foreign universities also, like sending the students or.
Yes, actually, I understand like people from outside they used to come for
Okay.
what we can say classes or this one because we have that Indian Institute of Space Science and Technology, na?
Yeah, yeah, yeah.
Already an institute.
IIST.
Yeah, Indian Institute of Space Science and Technology. Yeah,
Okay.
IAST.
Mm.
So
Okay.
there actually we have all the collaborations with various
And NASA,
universities.
you have collaboration with NASA also.
Of course, ISRO is having, that's why next
Yeah.
another 2 months we will be having some satellite collaborated with
Okay.
like
So they
NASA
have
also.
like some visits to NASA, some scientists go to NASA also sometime. Oh,
It may be there because at least
okay.
at level at our level it may not be, but higher levels may be there.
Okay. You are at which post? General manager.
Deputy General Manager.
Oh, deputy. Okay. So highest is the general.
No, highest is Chairman ISRO.
Okay, chairman. Okay.
Yeah.
Yeah. Takes like chairman is that Somnath? Or
Yes,
which
yes,
board?
yes, yes.
Okay, yeah.
Somnath sir is the current chairman. Yeah.
Okay, okay. Yeah, he was so popular in the news at that time, I heard.
Yeah, he's a very what we can say. He was our director when he was here.
Okay, okay.
Then only like after my earlier chairman left, he got he assumed the charge of chairmanship now.
Yeah. Okay. So you have got this place, like you have applied for scientist B initially, right?
It was C for me initially.
Okay, for so after the your BTech, after
After
your
my
B,
BTech, yeah, yeah, yeah.
okay, and you got the place, and then it's got increased the prost, the promotion, and
Yeah, yeah, yeah. Now I am in SG.
yeah, it's a similar process. I think is with the master students who apply with the gate.
Yes, yes. Master students.
DRDO, there is
Yeah,
DRDO
yeah,
organization.
DRDO is there. BARC also is there. Baba Atomic
Okay, okay,
Research, our atomic energy units also there, and our ISRO units also there. All three are there.
okay, okay.
Okay, anyway, thank you very much for
Yeah,
your
yeah,
support.
yeah.
Probably that because final why I was specifically telling that since
Is
we
it
are
helpful really in this course?
yes, yes, very much because this will be like when we do our what we can say like data interpretation.
Okay.
Definitely, this will be really helpful because we do generate a lot of
Okay, you
data. Then
collect
we
data and you just
yeah,
use these
exactly, exactly.
techniques or
Yeah, exactly. So that will be really helpful when we do a data to present it in a what we can say
yeah.
understandable way. So that way, numerical methods are really helpful, definitely.
Yeah, but you should try to understand these also, like what why this method is
Yeah,
important or
exactly. Yeah, sure. And now
then you
only
can
thing is that
use.
since we are like having one side work schedule and this also an additional,
Yeah.
so we spend
Is it
time
mandatory
after
for
hours.
you to do or you are just doing for your
No, no,
passion?
no, 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 no. It is like since I told no, PhD coursework is there.
Okay, okay, PhD
Myself
course.
and Mayuresh all are registered for this PhD coursework at IAST. So
You all
for
know each other.
yes, yes, he was in some other entity, not with us. Only
Yeah,
by like actually here more than 5,000 people are there, like around team of
yeah, yeah.
people. So he's also there, but he is in a different area, work area profile.
Okay, okay. Not from maths. No one's from
No,
maths.
none of us from Max. That is the problem.
Yeah, otherwise they
So
won't do that.
no, otherwise, actually, like it takes some time. That's what. So what we thought is that like in exams, if it is like questions are too tough,
Yeah,
whether
yes.
we will be able to finish it time, we will be solving the things fine, but still the time management will be really tough for us since we are not directly in this area.
Yeah, yeah, yeah. It's hard to sometimes to get up think with the things. Yeah.
That's why I
Yeah, if
just want to
someone
convey.
says me to study biology and mechanical and other sides, then it's hard for me, yeah, to understand things
Nevertheless,
sometimes.
we both are interested to learn this. That's why actually we were specifically selecting this one. And one of our friend also is there. Probably he was also there. He may be taking this classes online lecture sessions. He may be taking through video.
Okay.
because
Okay.
he is having some other classes where he has to attend in the same time. So most of our
Okay.
people, they
So
have
he
that
attended
difficulty.
the tutorials by recordings, or
Yes, yes,
is he?
yes, yes. Yeah.
Okay, okay, okay. Yeah. Okay, let's see. Maybe the time I adjust, but maybe or may
No,
not be. I'm not sure about
no,
the
sure. Anyway, now another 3 more weeks only, no, hardly.
Yeah, yeah, yeah. If you can attend it, that's yeah.
Okay, yeah, thank you very much, sir.
Yeah.
And shall I
Thank
take leave
you.
if you don't mind?
Yeah.
And one small request, because earlier I remember you posted that email ID. Can you just share it? I will just now itself mark that query to you in
Okay,
the
okay,
chat
yeah.
box.
You can, I can share you my email. Okay. Just- Mm, yeah, this is my email. Okay. Are you
Second, no,
is
I
it
am
visible
not.
to you?
No, I'm not seeing that. I think some chat option. Let me see.
Now you
Where
can
I,
see.
yeah, now sharing is visible. Just
Mm, how to
um,
share?
no, it is written somewhere. Yeah, 1 second, 1 second. Yeah, now meeting chat is. But okay, okay, once entered, I should be able to see. But the chat is not coming. Anyway, I will note it down.
Yeah.
Yash, what's 425?
I
Four two
will be
five.
taking, I think, next semester the linear algebra. You use linear algebra course, or you know that?
No, in linear algebra also, I think some of our what we can say friends they are
Okay,
they
okay.
are taking it. But
Yeah,
I
yeah.
think this is like season wise it gets changed, na? Like
What
season
else?
means maybe next is January to June it will be different course. Is it like that?
No, it will start from, I think, July to December.
Okay, July to December. Okay, so there actually it will not be MATLAB. So MATLAB will be in the next January only, if at all.
Yeah, yeah, yeah. MATLAB will not be there. It's based on linear algebra and matrix computations. Yeah, I think so.
Okay,
Yeah,
okay, fine, fine. Anyway, thank you very much, and I will
yeah.
just be in touch with
Okay.
you through email for that clarification, sir.
Yeah, yeah, yeah. Thank you. Bye.
Thank you. Bye.
Stop the